Hi everyone, today we are going to learn about the generative AI. So, this is the first lecture on generative AI, and today we will going to know about GAN. Most of people don't understand it, but I'm going to make it so simple that you will connect each thing. Now, let's just take an example. Suppose you want someone that it should generate something. Suppose we ask a model and let give the name model as g theta. It will help you. And then you have to provide some input to it, and then it will going to give you output. And this model is trained on lots of human images, and so this model is already trained. Now it will you have provided it input, and it will result in some output. And like how much the output is more related to a real human being, this measure the accuracy of the model. So the input we provided is not any image of human, like we want to model that it should generate some images like it, but we provide it some latent variable from a distribution. Like about the distribution, we have Gaussian distribution, and if you don't know about the distribution, I guess better if you read a few lines about it, like what is independent identical distribution, and how the what actually the graph mean. So like we have some distribution. Let's suppose it's pz, okay, and from it we just take out one sample, that name it z, and we provided it. So like you might be thinking, what actually a z is? Z is just a dimensional vector. It could be a tiny dimensional vector based on the what the dimension we have in the output. So you provided it, and then model will going to generate the output, and let give the name of the output is like it will go inside this function g naught. So here g naught, and then z, and then it will result some output. And then you have provided g1, then z1 and z2 and z3. So you will going to have many output images. So like here you're gonna have g1, z2, theta, g theta, z2, etc. And now you're going to have new distribution of the output. So like let me just check what is the name used here. Yeah, we have provided at g theta, and then so the output distribution, let's suppose it have a distribution now p output. So this is the new distribution of p output. But what you see that there is a actual distribution. If we actually go and see the actual distribution of human. So that's the original is p data. That's the actual original, and we call it true. This is true value, and this is one is predicted by the model, which the model have predicted in the output. And how we calculate the loss. Loss is actually how far is the like the predicted from the real or the true value. So here now the good model basically have a very almost the gap between is 0, and so you understand this model. And I also want to make something clear that model have many layers, like L1 layer, L2 layer, L3 layer. What these layer actually do inside them, these capture different features. One will capture the feature of eyes, one will capture the feature of mouth, eyes, etc. So this is the additional information I provide you. So let's just start. So yeah, we provided is some random latent variable from some distribution pz, and this is our model. It have many layer inside it. So like now we will going to put our input inside this model, and it will going to generate fake face. And it, like, if we run it multiple times, it will going to give us many faces and have its own distribution then. And what is actually a discriminator? Discriminator tells you how far the fake face, this is your prediction of the model, from the real face, as we talk that what is actually a loss. So like how you will going to calculate the loss is the actual true prediction is far from the predicted distribution, the predicted one. So this is the loss here, and then we have how we have to update weight. We use back propagation for updating the weights. And then what we do in it, suppose this is a weight, present weight, and like we subtract the partial derivative of loss with respect to weights we have. And then we have the new weight. This one is the now updated, this is the old. And here we also add learning rate function, we call it eta. So that's all about it. If you like this video, don't forget to subscribe my channel.